Hello, today we are going to learn power series. This is a very important section in this class, which is Calc 2. Um, After power series, we're going to learn two important series. Those are called Taylor series and then Maclaurin series. The power series is the start for Taylor series and Maclaurin series. So learning power series now is so important because that provides the foundation for the other two series. That means Taylor series and Maclaurin series. First of all, I'm going to give you the definition of power series. A power series about x equals 0 is a series of the form sigma n goes from 0 to infinity Cn x to the power n, which is C0 plus C1 x to the power 1 plus C2 x to the power 2 plus plus Cn x to the power n plus . This has infinitely many terms. Okay, so this is the expanded form of a power series. Okay, so one thing we have to understand, this is the power series about x equals 0. Normally we write the power series centered at a point. Alright, the point here is x equals 0. That is the place where this power series is centered at. And then in the next case, a power series about x equals a is a series of the form sigma n goes from 0 to infinity Cn x minus a to the power n. Okay, this can be written down as C0 plus C1 x minus a plus C2 x minus a to the power 2 plus plus Cn x minus a to the power n. Let me take this to the left hand side a little bit. Sorry. And here dot. Alright, so this is, in this case, this is a power series about x equals a. Okay, so you can see this a right here. Alright. Normally we write power series centered at a point. We can understand this later when we discuss examples. Okay, let's move to example number 1. Discuss convergence and divergence about the series sigma n goes from 0 to infinity x to the power n. If you expand this, the first term is 1, the second term is x, third term is x to the power 2, and some middle terms, and the nth term is x to the power n minus 1 plus dot dot dot. Let me write this as x to the power n. So this is the corresponding expanded form of the power series. All right. So you have to compute the convergence and divergence of this series. Okay. Once you see this series, you can understand this series is more likely this series. The only difference is all the constants, all the c values are just 1. In this case, c1 is 1, c2 is c0 is 1, c1 is 1, c2 is 1, cn is 1. All the c's are 1. So that's how you get this series. All right. All right. So now I'm going to compute convergence and divergence of this series. For that, what I'm going to use is the ratio test. Apply the ratio test. You have learned ratio test in the previous class. First of all, you have to understand what is the nth term. So that is the nth term. All right, now you have to compute rho, which is limit n goes to infinity an plus 1 over an here the an is x to the power n. I write limit n goes to infinity. An plus 1 is just x n plus 1 over x to the power n and the absolute of that. Okay, if you simplify this further, what you get is limit n x goes to infinity absolute of x. Okay, that is your rho. Here we have used the ratio test. If you recall the results of ratio test, the ratio test converges when rho less than 1. The series converges when rho less than 1, that is limit n goes to infinity absolute x should be less than 1. All right, that means this x should be less than 1. All right, that means the values of x should be smaller than 1 and greater than minus 1. All right, so you have learned absolute x in calc 1. So if absolute x less than 1, then this is the corresponding solution. All right, then just consider the divergence case. First of all, let me just write how do we get this result. We got this result by using the ratio test. Okay, and then the series diverges when rho is greater than 1. Again, this is by the ratio test. Alright, so that is limit n goes to infinity, absolute of x should be greater than 1. That should be greater than 1. That means x should be, this should be greater than 1, and this should be less than minus 1. Okay, so these are the solutions where the series converges and where the series diverges. This is the case converges, and this is the range of x values, and this is the case where the series diverges. So this is the range of x values. So we have this, the problem says discuss convergence and divergence. So we have discussed it is convergent when x is like that, it diverges when x is like that. All right. Good. Now again I'm going to give you a definition. The next definition. The interval of convergence of a power series is an interval containing all points containing all the points of x such that sigma n goes from 0 to infinity, Cn x minus a to the power n is convergent. Alright, here what we discussed was the interval of convergence. Okay, if it is asked to compute the interval of convergence, that is actually the interval of x values where the series convergent. The interval of x values where the series convergence. Alright, then we have another piece of this definition. So this is the first part of the definition. This is the next part. The radius of the interval of the interval of convergence is called radius of convergence. That is called radius of convergence. All right. So now this is radius of convergence. that is the radius of the interval. I can explain this later. All right, so go forward. I'm going to reconsider example number 1. Reconsider example 1. You saw that the previous series convergent in this interval. Okay, so that is called the interval of convergence. We observed that the interval of convergence is -1 to +1. Alright, that is actually the interval where this series convergent. It is right here, equation number 1, by equation number 1. Okay, now let's consider the radius of convergence. The radius of convergence is, here the radius is 1. You know, the interval is from -1 to +1. That is, it is like this. If this is the number line, so here you have -1, here 0, here +1. So this is how the interval will look. And then the radius is actually that. That is the radius. Alright, now let's move to example number 2. This is the given series to you. N goes from 1 to infinity. X minus 1 to the power n over n. Find the interval of convergence and the radius of convergence. Okay, you have to find the interval of convergence and radius of convergence. First of all, we have to find out where this function converges. Okay, first we have to find all the x values, where this function is convergent. Alright, first of all you have to understand what the n term So you write an equals x minus 1 to the power n over n. Alright, then compute rho, which is limit n goes to infinity an plus 1 over an. This is the ratio test. This is limit n goes to infinity. An plus 1 means x minus 1 to the power n plus 1 divided by n plus 1. An is x minus 1 to the power n divided by n. Alright. Now you have to cancel terms. Let me rearrange this series. I can write this down. I can write this as limit n goes to infinity. I can just work on this inside part and then write x minus 1 n plus 1 over x minus 1 n, and here n over n plus 1, absolute of that. Alright, and then if you simplify further, you will get limit n goes to infinity x minus 1, absolute of that, n over n plus 1, absolute of that. And then you can see this x minus 1 part is independent of this n, so you can take this part out. Okay, so that you can take x minus 1 out from this limit. So you can write x minus 1 absolute limit n goes to infinity n over n plus 1. Alright. You can just drop the absolute sign. You can just drop that absolute sign because n over n plus 1 is always positive. Alright, now just simplify further. This equals x minus 1. Keep x minus 1 as it is, and then you have to work on that part. You write limit n goes to infinity. What you do is you divide numerator and denominator by n. If you divide the numerator by n, it should be, let me divide like this, n over n, n plus 1 over n. Alright, and then you write this as x minus 1 absolute of that limit n goes to infinity 1 over 1 plus 1 over n, and then apply the limit. You will get x minus 1 absolute, and then here you will get 1 over 1 plus 0, and finally you will get x minus 1 absolute. That is your rho. Alright, that's what you get for rho. And then you have to determine the x values where this function, where this series converges. Alright, you have to find out x values where this function converges. Alright, so where this the x values where this function converges given by rho smaller than 1. Alright, so rho smaller than 1. That means x minus 1 should be smaller than 1. Alright. Okay, so go forward. Let me take this out for now. I will write it later. By the ratio test, the series is convergent when rho is less than 1 that is x minus 1 is less than 1. Okay, that is x minus 1 is less than 1. Now you have to solve this for x. You have to solve this for x. Solving this for x is actually Calc 1 materials. Alright, so you have to solve this for x. For that, what I would do is I consider two cases. The first case is interior. This part is positive. The next case is this part is negative. Okay, I'm going to consider two cases. Before that, let me write this statement. Solve for x. That's what I'm going to do. You have to solve that for x. I'm going to consider two cases. Case 1, where x minus 1 is positive. If x minus 1 is positive, if this interior is positive, then you can simply drop the absolute sign. Okay, so what I'm saying is, if that is positive, then you have x minus 1, absolute of x minus 1 is simply x minus 1. Okay, that is the given inequality will become x minus 1 less than 1, and then this will give you x is less than 2. Okay, so this is one solution. So this is one solution. You have to get the second solution. For that, I'm going to case 2. Case 2. That is x minus 1 is negative. Okay, if x minus 1 is negative, you can simply drop the absolute sign. If you want to drop the absolute sign, you have to replace it by a negative sign. So you have to introduce a negative sign if you just drop the absolute sign, because interior, the inside is negative. All right, that's, you have learned this in Calc 1. You might you definitely remember this. That is, you write minus x minus 1 less than 1, and then just you multiply by negative x plus 1 less than 1, and then you write negative x that, and then negative x less than 0. Then finally you write x is greater than 0. This is the second case. You can get this one from the first case, you can get that one from the second case, and then you can have to combine them. Okay, this is from 1, that is from 2, then by 1 and 2, you write x should be greater than 0, smaller than 2. Okay, now the interval of convergence is this. That is the interval of convergence, but you have to put that in an interval format. Okay, thus the interval of convergence is 0 to 2. That's the interval of convergence. The radius of convergence, let me put simple letters, lowercase letters. The radius here is actually 1. It is from it's from 0 to 2. So the radius is this, which is 1. Alright, radius is 1. Let's move to example number 3. Find the radius and interval of convergence find the radius and interval of convergence of this series sigma n goes from 0 to infinity n x plus 2 to the power n divided by 3 to the power n plus 1. Alright. First of all, you have to understand the nth term. This is the nth term. That is an equals n times x plus 2 to the power n divided by 3 n plus 1. Now rho equals limit n goes to infinity an plus 1 over an. This is limit n goes to infinity. An plus 1 is actually n plus 1 x plus 2 to the power n plus 1 divided by 3 n plus 1 plus 1. And then nth term should be n x plus 2 to the power n divided by 3 to the power n plus 1, and the absolute of the everything. Okay, so this is a hard problem. So go forward. So you write this to be limit n goes to infinity, and then what you do is you flip this denominator and bring forward. Then you write this as n plus 1 x plus 2 to the power n plus 1. Here you write 3 n plus 2 multiplied by 3 n plus 1 divided by n times x plus 2 to the power n. Limit n goes to infinity, and then you rewrite this as n plus 1 over n. I will just associate similar terms, and then what I write, x plus 2, here n plus 1, here x plus 2, here n, and then 3n plus 1, here 3n plus 2, absolute of that. Okay, now I'm going to simplify it. Limit n goes to infinity. This is n plus 1 over n, and then this is x plus 2, parenthesis, and then this is 1 over 3, the absolute of that. Now you can see this is independent of n, that is independent of n. So you can take both of the parts out from this limit sign. I write this as x plus 2 absolute 1/3 and then I write limit n goes to infinity n plus 1 over n. I don't need to put absolute here because this is always positive. Alright, so I write this as 1/3 x plus 2 absolute, and then before applying the limit I just divide the numerator and denominator by n. So I write n plus 1 divided by n divided by n, and then this is 1/3 x plus 2 limit n goes to infinity. Here this should be 1 plus 1 over n over 1. Alright, so this is equal 1/3 x plus 2 absolute, and then when n goes to infinity this is 1 plus 0 over 1. Okay, so this is simply 1/3 x plus 2 absolute. So this is your rho. Alright, now you found rho. You know that this series converges when rho is less than 1. Alright, you write here by the ratio test the series is convergent when rho is less than 1, that is 1/3 x plus 2 absolute is less than 1, then that means x plus 2 absolute is less than 3. Alright, now you have to solve this for x. That is already learned in Calc 1. So you could use your Calc 1 knowledge. Solve for x. Okay, again, like we did before, we have to consider two cases. Case 1, in case 1 we consider x plus 2 is positive. Okay, if it is positive, then you have x plus 2 absolute should be just x plus 2. You can just drop the absolute sign if the interior is positive. Then that means this is actually x plus 2 less than 3, and then you simplify this. X less than 3 minus 2, x is less than 1. Take this as equation number 1 and then move to case 2. Okay, in case 2 we consider that part is negative. If the interior is negative, you can just replace absolute by a negative sign. Okay, you have learned this in Calc 1. Then you write x plus 2 absolute less than 3 can be written down as negative x plus 2 less than 3, and then you just remove parentheses. You write just negative x, negative 2 less than 3, and then what you do, you just push this x to this side and bring this 3 to that side. So what you write is negative 2 Once you bring this 3 to the other side, you write negative 3. Once you bring this negative x to the other side, it will be positive x. Alright, that's how it works. And then you simplify. This is negative 5 greater than x. So this is equation number 2. Alright, then by 1 and 2 you write give me a second, x is smaller than 1 greater than negative 5. Alright, now you can understand what's the radius and what's the interval of convergence. Thus, the interval of convergence is negative 5, 1. Okay. The radius of convergence is, here this is negative 5, this is 1, and the midpoint should be minus 2. So the radius from here to here is just 3. Radius equals 3. Okay, the radius of convergence is 3. Alright, so that is the end of the third example. In this section we discussed 3 problems, 3 good problems, if we come from the beginning. So first of all, we gave the definition of power series, and then we discussed one problem right here. Alright, and then we understood how we define rate of convergence, and then how do we define interval of convergence, and then radius of convergence. And then we move to example number 2, which is a little bit complicated than example number 1. In example number 2, we found what is the interval of convergence and the radius of convergence, and we move to example number 3, which is even complicated. And finally we got the interval of convergence and the radius of convergence. So the third example is the hardest type of example that you could think of. Alright, so thank you very much.